So this is the circuit diagram for parallel operation of two transformers. Keep in mind that these two transformers are dissimilar transformer, and the positioning of the transformer is the basic thing. First, you need to keep 2 kVA transformer. Second will be 1 kVA transformer. Come to the points. Here, 230 and 230 of 2 kVA and 1 kVA transformer are shorted, 0 and 0 are shorted. Now from any 230 terminal we have given to the single phase supply. So we have given to the R and the neutral is given from 0. As you can see over here. This is the primary connection we did now. Let's move to the secondary. From secondary, now from 230 of first transformer, we will be giving to the ammeter. Then ammeters is given to the M. Here M and C are shorted, and L of this W1 wattmeter is shorted with the L of the W2 wattmeter. We will come to the wattmeter 2 connection later. Now coming to the switch connection. From secondary terminal of first transformer, we will be giving to the red terminal of the switch, and then the another terminal, black one, it will be directly shorted to the double pole switch neutral. Coming to this voltmeter, we will be connecting a voltmeter across the switch so that it will read some voltages. If at all, if you have connected and we are giving the supply, if at all it reads the double the voltage, then it means that your circuit connections is wrong. So we need to change the polarities. Coming to this wattmeter connection, we will be giving the 230 of 1 kVA transformer to the ammeter. From ammeter again to the M. M and C are sorted, and L is given to the switch. Keep in mind the switch positioning should be in this pattern only, because here this is RYB, this is the phase we have considered. So phase should be in line with phase. That's why we have kept the positioning of the switch in this way. Coming to this, L is shorted and given to this. Then V of this first wattmeter is given to the second wattmeter is given to the 0 terminal of 1 kVA. Again, V of first wattmeter is given to the 2 kVA transformer 0. Now what happens is, now this terminal is given to the 0 of this second transformer. Now till here the primary of switch is connected. Now come to the secondary, but before that, in the circuit diagram, we see this voltmeter is connected after switch, but doing the experiment we will be connecting before that switch connection. So strictly you should know that this voltmeter will be connected across this, because this is the voltage across the whole circuit we will be measuring. So which will not be after the switch, it should be before the switch connections. After this, from this terminal, again we will give to the ammeter. From ammeter to M, M and C are shorted. From L, we will give to the one terminal of this. And keep in mind these things should be in star connected. This terminal is given to the neutral of the switch, and the V of wattmeter 1 is also connected to the neutral of this. Now if we switch on the all experimental setup, we will be taking some readings. Now we will be finding out the kVA ratings of that one. So we will be finding out that I rated of these two transformers, and within the range only we need to take the two readings. We will take first reading from approximately 235. You can take any between the ranges of 2 to 8 amperes, because 2.4 is the I rated for 1 kVA transformer, 8.9 is the I rated for another transformer. So your readings should range between 2 amperes to 8 amperes. This is the 3 readings, or more than 3 readings you can take. We will be calculating K. This is the wattmeter constant, which is need to be multiplied with the wattmeters. After taking these values, we will be doing a short circuit test. Circuit test, we are not going to do this. I will explain you through this diagram. We will connect one single phase variac to the AC single phase supply, and across that we will be connecting one 230 voltmeter. That now from the phase of this single phase variac will be given to the ammeter M, and then wattmeter M. M and C are shorted. L is given to this 230. And V is given to the 0 of single phase variac. Now see, this is short circuit test, means secondary should be shorted. We have shorted this, and we will be taking these readings. There will be two transformers, we have taken 2 kVA and 1 kVA. So we will be doing the short circuit test for the both transformers, 2 kVA and 1 kVA. And keep in mind that short circuit will be done under the rated current only. So we will be taking the rated current only. Now here we will be calculating the experimental values, and we conclude from this we will be calculating the theoretical values, and we will be calculating the theoretical values, and we will see the experimental values. If they are matching, then the load sharing of the two transformers is done, and it is how the experimental setup works.